So this is the second page of the test. I'm going to go ahead, we're going to get started. So using the velocity graph, we want to determine the displacement during the following time intervals, so let's be careful. To get the displacement, it's very much like getting the distance. So if you remember, we get how far a particle goes by getting its velocity times its time. And if we want the distance, we take the absolute value. And if we want the displacement, we subtract the initial position. So in this case, we're saying the initial position for this, we assume that it's 0, so that's why I just write this as v0 times t. So what that means is here, if v0 in this case is negative 40, and this length here is 15, and this depth here is negative 40, it looks like I can actually calculate displacements by getting areas under graphs, just like this. So when I take 15 times negative 40, I'm going to end up getting negative 600 meters for my displacement. I repeat the process here. So this width is 10, and I have positive 40 here. And so I end up getting plus 400 meters for my displacement. Finally, for this part is 0, because my height is 0. And for this last part, again, my time spans 15 seconds. My velocity is negative 80. So for my last part, my displacement is negative 80 times 15, which works out to negative 1,200 meters. That doesn't mean I'm at a position of negative 1,200 meters. It means it's from wherever I ended up at 35 seconds, I'm moving negative 1,200 meters from there. So now what I want to do is I want to go ahead and actually draw out my position versus time graph. So what I'm going to do here is I'm going to actually magnify this quite a bit. Hopefully this works. And I'm going to go ahead and set up my axes, label everything, and get a decent graph going. So here we go. So the first thing is I notice here that, man, I got a lot of negative numbers in my answers. So I'm going to actually skew my axes like this. So 3, 4, 5, 6. So I'm going to label in increments of 200, and I'm going to make this my time axis right here, like that. And so I'm going to have 200, 400, 600, 800, 1,000, 1,200, 1,400, and label it like this. So I got negative 200, negative 400, negative 600, negative 800, negative 1,000, negative 1,200, and negative 1,400. Anybody who looked at this and thought that for some reason you needed to put negative 40 on this axis, that's the speed, or rather the velocity. It is not the position, so be careful. And I'm going all the way to 50 seconds. So how many squares do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17. Okay, so let me try this. Let me try counting by twos. So this will be 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. So if you notice, my choice was bad. Not a good choice because I couldn't go up to 50. So now I'm going to try to do this again. I'm really glad we saw that. So let's try this. 10, 20, oh, let's try this. Maybe we can do this. So let's do 10, 20, 30, 40, 50. So that makes this 5, 10, 15, 20, 20. So I got to be really careful in my counting. I'm really glad you guys are seeing this because I want you to see that this is not like a perfect process. So this is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So 10, 20, 30, 40, 50 seconds. Perfect. Now, I know that my slope is negative 40 for the first part. So what does that mean? That means that for every 10 seconds, I'm going to go down 400 meters. So that means when I'm at 15, I should wind up at negative 600. So I'm just using the fact that I can't really go over 1 and down 40, so I can go over 10 and down 400. And that means if I go over 5, I'll go down another 200. So at 15 seconds, I end up right here. Now what happens? Next, I'm going to end up going forward for 10 seconds, a total of 400 meters. So using that slope idea, here I am at 25, and I'll go back up to 200, like that, negative 200, like that. Finally, I pause for 10 seconds, so from 25 to 35, I stay totally paused. And then what happens? I actually end up going down from 35 to 50. My slope is actually negative 80, so it's twice what it was before. So that means for every 10, I'm going to end up going down actually 800. And so when I wind up at 50, I end up at negative 1400 when I actually do that calculation. So that's supposed to be a nice straight line. It's really horribly drawn. I apologize for that. But this is what the graph ends up looking like. So that's problems 3 and 4.